Okay.
Good morning, everybody. Welcome to the crop modeling webinar, the second one, at least from this fall. And if I can get my computer working here, we'll go back to the prior slide. Okay. We have at least John Hargraves online, so we will have some impact from EPSIM modelers, and I've been really pleased with the surveillance, I would say, and evaluation of the EPSIM model runs and files that they've been doing, so I very much appreciate that. The goals in this crop modeling webinar will be to evaluate the model setups, both the individual files, the domes, overlays, and in some cases actually trying to look at the individual crop model files so that there are not issues with the translation. And we need to do this before we actually do the simulations of impact assessments and adaptations. So we're going to look at the survey and overlay files, discuss assumptions, show some of the probability of exceedance plots of the farm survey yields, and then also evaluate CTWN. And I would say we're about 80–90% of the way through this with what I call one-on-one interactions, DSAT modelers, EPSIM modelers with the individual regional teams. I won't say we're totally done with this. I have one or two that have not followed through up with the DSAT, and I think EPSIM is still in option. But the goal here is that I'd like to see all of the setups be totally resolved within the next several weeks, so that when we get so that you're ready to do climate scenarios with Alex Rowan to do baseline and the scenarios, and somewhere into January we will get the wraps and adaptations. So are there any questions with what we'll do with the goals? Okay, I have about 8 more slides, and then we'll get into some individual discussions. Now, some of this is a repeat from last time, but I think it's worth presenting again, because even with some of the redos, we're finding some cases of I would guess, issues of using the data entry forms and the domes, overlays. For example, there's something called CLCF, coarse fraction. Coarse fraction, both in the overlay or in the soil files, is meant to be only stones. Don't put sand in that category. And if you create your soil, do not put sand in the category of a pedotransfer function. Don't put sand in the coarse fraction, or you get a very low water holding capacity. We've also decided that if you have each individual soil may have its own unique characteristics of rooting and initial conditions, so it's logical that there should be one field overlay dome per soil. We saw 1 or 2 cases where the models seem to be running with fixed harvest date, and that is particularly not good if you go to future climate scenarios, because then temperature will not change your simulated harvest. So do not use HADA in the survey or the dome data. I think I remember seeing this in either the Pakistani or IGB simulations, that was still happening. In the dome overlay, occasionally there's something that affects the same variable. One of these is in the DSAT structure of the soil files. There's an sRGF, which defines the shape of the rooting profile. If you do it there, you should not need to use the dome overlay to reset it. So if you use the SLRGF, which is the same in the dome, and you do replace, it will give you a different profile shape. So be sure you're not doing things twice. If you're using the dome, the fill command just fills if it's missing, which is reasonable. If you use the word replace, then that's what controls. And not only the routing, but initial conditions nitrogen. If you set initial nitrate ammonium with a profile shape, initial nitrate and ammonium, then you should not need to set the same thing with kilos of nitrogen distributed over the profile. So take one approach, but not both. Same thing somewhat happens with the SOM3, and this is the DSAT, stable carbon. SLSC is the variable for that. The ABSIM folks use a transpose function to affect their fraction inert. Okay, a little bit about model concerns. Those of you using the DSAT, just be a little bit wary of adjusting the wrong thing to get the right answer. And if you go too low on this SLPF value, especially for non-legumes, when you should be keeping down the nitrogen mineralization characteristics, and that's mostly affected by what you do with the fraction stable organic matter, which should be going up if you're trying to reduce the yield under low fertility. I'll skip this on rice. I think that's been solved. But cereus rice does have volatilization if the urea is not incorporated, and you need to take a look at how that happens, and you might get a different nitrogen response. This is only 2 teams that may have that problem. I think this next problem has been solved, and that is the use of finding a -99 in soil carbon. And one point that we'll discuss probably some more is that what you do for initial conditions, nitrate, ammonium, soil organic matter, and especially this stable carbon or fraction inert, you will get a different response to nitrogen fertilization with DSAT EPSIM. So you need to be aware of that, and those 2 variables, the SOM3 and fraction inert, operate somewhat differently to accomplish the same thing. There's some other issues not related to models. I think this first one has been solved. Probability of exceedance function on the upper left has to start at 1. I think the next one has been solved, and it's only one group. This was the South African working with district yields over historical years, and detrending would be needed there. The next problem, I believe, has been solved as well, but we saw back on the first a month ago some soils with as low as 4 to 5% volumetric. That tells me there's a problem generally, unless you've got a pure sand. And what will happen if you use a pitot transfer function where you put the sand fraction in the coarse, that will give you that type of output, because coarse fraction has no water holding capacity. It's just blocking off. Let's say you put coarse fraction 80%. That means only 20% of your soils are doing some water holding characteristics. There's another problem with soil water sometimes, and this can be an output even from the pitot transfer function, Saxton and Rawls, and in the S-build. You get a drained upper limit that's very close to the saturated upper limit value. And that occasionally can cause some problems, especially in some of the DSAT models, where you get excess water, airspace goes to 0, and then you actually get root killing and the roots don't grow in the soil layers. Typically you don't want that, so you should be looking at drained upper limit being about 0.05 to low sat. I think what causes that is an incorrect bulk density. So bulk density entry affects that. There's another issue that I think is fixed, and that is that the nitrogen response in CTWN failed with an old version of the Quad UI. So if your version is prior to, say, October, be sure that you downloaded the latest Quad UI for that purpose. And basically, you're not getting a response to nitrogen with the DSAT maze model, for example. There are some little issues, I think, that, and particularly we'll get into the AppSim modeling group, discovering a lot of this. You will see it when you start looking at the response of a non-legume to nitrogen fertilization. And this is that you need to be careful setting the stable carbon for the DSAT and fraction inert for AppSim. And the thing that can help you with that is to think about the ability to predict yield for a non-fertilized plot without nitrogen fertilizer. A lot of you are operating in environments where you know the yield levels with no fertilizer applied in a generic sense, and you need to be able to roughly reproduce that. Another thing in the initial conditions, if you have very high initial nitrate or ammonium, you can also affect response to fertilizer N. I've seen one or two cases. If you see what's called organic amendment section, that's only for animal manure. Prior crop residue goes into the initial conditions section. Organic amendments, just historically with the DSAT, was meant if you had green manure that you plowed in, but in your case, you're really thinking only animal manure for the organic amendment section. I saw one or two cases with very high water holding capacity. I'm not sure whether it was Pakistan or India, IGB, I believe. 30% water holding capacity is almost an unacceptable number. So if you get to think about where the range occurs. I discussed this before, but if you're setting the root length density shape in the soil file, then you don't need to use it in the overlay. Now, what's in bold on the bottom here is just a generic statement. We need for all the teams, and there's a few that have not finished this yet, to complete their analysis of the farm survey for all the crops they plan to do. Send in the probability of exceedance plots on that, and then to do CTWN for all the crops. Now, so far we've only done maize and also wheat and rice. There are other teams that are doing some of the other crops, like suara, sorghum, peanut. I believe chickpea was done with CTW, because we can pick up some other issues there if we see those. Okay, this is an old slide, but I think it still illustrates probability of exceedance. And this is from the SWAR group, and it's old. They've moved beyond this. But basically, if you have this blue line, which is observed farmer distribution of yields, then you would like the crop models to mimic this. And in this case, you want roughly the same mean and roughly the same shape of the frequency distribution. I had given some examples here that this one, possibly the cultivar was not with sufficient productivity, or it was a low SLPF, or water holding capacity because it's below. The AppSim case here for peanut, and this is a legume, so it may be fixing nitrogen, so that distribution may be not enough variation among soils in their water holding capacity and other traits. This is a slide from last time as well, and I think the teams have improved on this, and I know Chickpea has sent in a new one. But the issue would be, again, that you're trying to mimic this probability of exceedance, and you don't need this to be perfect, but you do need a shape that's about the same with the mean the same. And in this case, this model's not quite picking up the variation. And this was the Maze team Eclipse, and this again is old. I think they've got a new one. So think about the reasons for why your probability of exceedance plot may have tails on the upper at low yields or at high yields that are not right. So here's the last slide. Remember to document your cultivar calibrations all the way prior to this. Later, either the end of this month or in early January, Cheryl Porter will be asking you to provide actually the files that describe the files with the weather and the data and the cultivar calibration, in addition to the farm survey data and baseline and climate scenarios and adaptation. And along the way that you've been making these adjustments to the soils to mimic the farm survey distribution, be sure you document and defend those assumptions. Initial conditions for soil water, soil carbon, stable carbon pools, prior residue, initial nitrate ammonium, and even what you do with this SLPF fertility thing in the DSAT. So describe causes for the survey yield distributions, and where you still have questions, be sure you reach out to AppSim and DSAT modelers. Last point, and I brought this up before too, I see two papers resulting from the CTW, one of them on maize and another on, I think, the wheat rice. It's a logical separation because the crops are different. Maize is grown rain-fed. The wheat and rice are basically irrigated or paddy, and they're also in a specific region. And it looks like we should get a good, so far things are looking pretty good. So let me ask at this point if there are questions, and then I'll show some individual results from teams. We have 26 people now. Devotee says no voice.
Devotee, does that mean that you are not, well, that's a silly question. If you can't hear me, you can't hear me. I'll respond by chat.
Type it back. You know, they may need to click on the green audio at the, well, that's for them to speak. That's not the same, is it? Try out the volume on the on your own computer. I'm going to show a few. At this point, please send in a comment, written comment, if you're not wanting to speak live, and we'll try to address that. But I'll go through a set of showing some results from teams. And the one that I just brought up is from Suara. So, and I would encourage Dillies, if she's on, or Bright, if you want to make comments during this, we'll bring you online if it works. This is the set of probability of exceedance graphs that were done for the Tamale location in Ghana. And this team, the West African team, did maize, sorghum, and peanut, groundnut. In this case, the black are the observations. And my guess is what the steps mean is that there's roughly about 12 to 15 observations here, so that's not the same huge number that we saw in the others to make that smooth. The model simulations, they seem to do a pretty good job of having the model calibration both for the maize and the peanut. The sorghum in this case, I think with the DSAT, possibly there's an issue with providing too much water holding capacity, or the roots are too deep. Now what I think that the AppSim group will probably agree with me. I took a lot of look. They created their variation by varying soils, water holding capacity, depth of the soil, and some of those characteristics, including to some extent the soil stable carbon. So that's how they were arriving at this distribution. I would make one caution. The AppSim group is right that it's important to reduce the yields mostly with nitrogen limitation, water limitation to the right level, rather than in the DSAT. You can use this SLPF fertility value, but that should be relatively a last resort. That accounts for something like phosphorus deficiency that's not there. You should be working with the nitrogen, stable carbon, and water holding capacity to mimic those distributions. This is the CO2 sensitivity with the CTWN. On the left at 30 kilos of nitrogen, and on the right 180 kilos. And the yield level is a little higher here, but there's probably something else limiting yield there. But the maize model is not very responsive to CO2, a little more responsive under high nitrogen than low nitrogen, and that looks quite good to me. Here's the temperature sensitivity of the two models. The blue is DSAT, series maize, and the red is AppSim. And this is something that's consistent that we have seen. We may have made the series maize model too sensitive to temperature, but we won't know until someone has real data that says which of these cases are right. So the models are different in their temperature sensitivity when you move up, say, +4 and above. Here's the rainfall sensitivity. And reducing rainfall quite nicely gives about the same response. And this would be a statement that you're doing roughly the correct thing with the water holding capacity, soil depth. Here's nitrogen sensitivity. And again, both models giving about the same shape of response. Plateau about 100 kilos of nitrogen, and going down to very low. And this is my point about where you set initial nitrogen, nitrate ammonium, and the stable carbon pools. And they've apparently done a very good job of working through this with stable pools, the soil depth, and this is a low organic matter soil. In this case, they're able to mimic both pretty well. And that's the last one on the Sawara. Anybody from Sawara want to comment? No comment? Okay. Next one I'm going to show will be the Sawara. I can pick it up. Narongo. It's a different site also in Ghana. And again, they worked with maize, sorghum, and peanut, and this is even, I think, well, it's also shallow soil. And the same principles applied here, that they had quite shallow soils, low organic matter, and worked hard to vary the soils. They had, I believe, 4 to 6 soils. And we think it's acceptable to generically change traits by soils. It would be best if someone actually was in that farmer's field and measuring that on that farm, but in fact that's not been done. The contrast would be that I guess 2 years ago one of the teams was microcalibrating every field, and I think that would be going overboard. They thought that sorghum had deeper rooting, so they created a deeper soil, but I'm not so sure for the DSAT that that's true. See, that's the whole line for sorghum is above the observed. Here's the CTWN for maize at the other site, and as before, the yield levels are very different here, about 1,700, 4,000, but the response is mostly flat with 0 in like it should be, some response under high nitrogen. Here's a response to temperature, and pointed out before, the series maize model decreases yield with temperature if you start going above +2. The EPSIM, I'm a little concerned about total linearity here and coming down, but that I'm not sure what's causing that. Rainfall probability, reduce yield if you go to very low rainfall, but this is a very high rainfall environment, and actually increasing rainfall leaches the nitrogen out, so this is not a surprise, okay, if you have water and nitrogen balance turned on. Here's response to nitrogen, and again they've done a very good job. This soil has a little bit hot, well, not that much, about 300 to 500 kilos per hectare at 0 fertilization, but pretty well the same response shape with both models. Questions on this?
Ken, there was a specific question in the chat about a CTW response. I don't know whether you want to get into that yet or not, but
Good.
So it has to do with, without having the graph in front of us, it might be hard to comment on it, but it has to do with rainfall, the rainfall response at a particular site. So Bhuvana, can you, is your microphone activated? Do you want to describe the problem?
Hello, can you hear me?
Yes, we can hear you.
Hello. Yeah. Good evening. I am Bona from TNU.
Yes.
Hello. Actually, I have sent you a mail regarding this doubt CTWN. Whenever the rainfall is increasing, the result yield also getting increased. Actually, this is the irrigated maize. Then how the yield get reduced for 25% of the yield, I mean reduction in the rainfall?
I suspect that, are you
irrigating sufficient amount, then only 25% of the rainfall reduction is there, then how the yield is reducing to 7-10 kgs, the simulated yield?
You're with South India team, right?
I shared all the files regarding, I mean, what I have used in the CTWN analysis.
Let me try to put up your PowerPoint. See if I can.
Through mail, I guess.
Ken, in the South India team, only chickpea is available. They have not done that.
Okay,
they have not sent in the PowerPoint.
Bhavan, what team are you with, Bhavan?
She is with South India only, but we have only concentrated only one crop this time, so
okay.
she is working on that.
Sorry, I'm trying to figure out where Bhavan is. What team are you with, Bhavan?
She's with South India, but I don't know that we have the graph, so it might be hard to comment on. But I think that the problem is that it's irrigated and that it's showing too much response. She didn't expect as much response from an irrigated crop.
Well, I think that there's two issues with that. One is if the irrigation is relatively small, it's possible to get a response if you're reducing the rainfall.
He must be having that first.
If you're doing fixed irrigations and the amount of irrigation is low, and then you start reducing the rainfall that is already occurring, then I think it's possible. And we do know that the descent model is a little more water demanding than AppSim. So if that's what you see as a characteristic, it's possible.
November 9th, I have sent that mail to Ken Bhupe. You can download the figure from your.
I'm sorry, I'm not somehow the Indian dialect's not connecting with me.
Okay.
Maybe you can type it into the chat window.
Yeah. I think this is something we probably should try to address offline. Send us the specific files and we'll try to work with that. Okay?
Okay. When I have to send that file?
Do you understand, Cheryl?
I couldn't hear that.
I can hear, but
I'm
I
not
can't.
able to hear properly. Hello? It's not audible to me.
Yeah, I mean, I can hear you, but I'm having a hard time understanding.
I'm not understanding either, Cheryl. I think we need to go discuss this offline with email exchange, okay?
Oh, okay.
Okay? Sorry.
Okay. That's okay.
I have several other teams' presentations here that I'll try. I have one from Pakistan that I'm going to bring up here.
Ken, I wonder if the AppSim group has some general type comments that they want to
Yes.
discuss.
John Hargraves. Are you on mute, John? No response.
Yeah, we're not hearing you if you're trying to talk. Okay, I heard John Hargraves earlier, but I'm not hearing anything now.
Okay.
Hello?
Yeah, now we can hear you.
Hello?
Yeah.
Okay. I'm having trouble with my mute button.
Well, we can hear you now.
Good. Yeah, with the AppSim stuff that I was working on with Pakistan, a lot of the issues were with the starting conditions, but also John Dines and myself have both observed that the soil organic parameters weren't very well parameterized. Particularly the F inert and the biome too. So John might like to comment because I see he's online now. He did a lot of work with the West African group and the East African group. John?
I understand the F inert. Tell us what the F biome is doing that creates a big difference. This is the active fraction. Silence.
Yeah, okay. I can see he's there. John?
Yeah, I just got back.
Okay.
Okay.
The
Okay.
question is the
I can. Ken, could you state that question to John, please?
Yes. You mentioned the F inert and the F biome as two important characteristics to set. I understand F inert basically is the stable organic carbon that in fact has no mineralization.
Yep, that's correct.
But F inert, I mean F biome, that is the active fraction?
It's the more labile portion of the active fraction.
Okay, and you do need to set that.
Yes, you do. Yeah.
Okay, was not aware of that.
Yeah. So there's the F biome pool, which is the labile pool associated with the microbial biomass, and then there's the humic pool. So the biome and the humic make up the active portion that mineralizes.
So what's the advice to everybody who's trying to set those two?
It's actually set through F inert, which sets the stable or inactive pool.
Right.
And then you set the biome according to the F biome input column, and then the humic fraction is by difference. So, and the levels that I recommend for F biome is around 0.02 to 0.04 in the surface, and then a transition layer in the second layer, maybe 0.015, and then 0.01 for the remainder of the profile.
Okay.
The 0.02 in the surface would be a rundown soil, and 0.04 in the surface would represent something like a legume rotation.
Okay. So what happens when you have teams that have varying yields in the survey farms, but they're really very uncomfortable with what actually was preceding that in the soils for those sites?
Yeah, previously I'd seen values that were low in the surface and increasing to depth. And I think that's more or less been fixed up now. That most people have it high in the surface layer and reducing with depth.
Yeah, if they were confusing this with the other, the stable fraction, then they were going exactly wrong direction.
Yes, exactly. Yeah.
I think that's easy to have done.
Yeah.
This reminds me we almost need to write down a little set of generalizations for all these folks after this experience. Anything else, John Dimes or John Hargraves?
No, I've just come into the discussion, so I don't know what's been said.
Well, so we're just we're looking for sort of generalities on things that that people, in general, people are getting wrong. You know, just not specifics necessarily any one team, but what do you typically see that needs correction? So Ken went through a whole list of things that are generic to both models pretty much, but I just wondered if there were any things that the AppSim group, you've been very active in helping these teams, so we thought maybe you had some generalized words of wisdom.
What I have seen here is that the AppSim folks have highlighted that initializing soil, both nitrate, ammonium, soil carbon, those three pools, the F inert, F biome, and the vertical distribution is, they have really emphasized the soils end of this, and that's good.
Can I make one comment which I hope the AppSim people can help me on that sort of a feedback?
Go ahead, David.
Yeah. Okay, because I've been reviewing the field overlay we're doing with SAMIP, and I noticed that several times the KL factor in the field overlay is quite low in our case. I'm not sure about other teams, but I wanted to clarify, and they can correct me if I'm wrong, because the KL is just the maximum rate, basically, at which the crops will extract water for a given layer within a soil. So that's basically, it's dependent on the crop, obviously, and it's a maximum limit, and it's not an actual rate. So if there are no reason for lowering the value, it shouldn't be touched. Otherwise, I'm not sure why that has been lowered so much in our case, which I modified it now. But that's probably something that it's useful if other team will look into it, and if that has been touched or modified, then what was the reason for that? If there were nematodes, that would be okay to modify it, but if not, I don't think that should be touched.
Yeah, I concur with that. That I never change the KL value.
You keep it constant at 0.06 or for a given
it varies with the different crops.
Okay.
Some between 0.06 to 0.08, and John Hargraves can say more, but it can decrease with depth. I tend to use what comes with default values in the APSIM soil database for the different crops.
The problem is that our groups are not getting that out of the translator, so they have to go back to learning the APSIM.
Well, I think if you use a value of 0.07, it might be a safe midpoint.
Okay, there is in the field overlay a option for filling KL, and at some point in the past, probably Cheryl can function applied to the KL as well. But I think if it's a medium value, like just fill, that should work.
There is a KL variable. I think it's APSIM _KL that you can use. And also I see a note from Stradar that about setting F biome and F inert. We do have variables in ICASA for both of those. So F biome is SLFAC, and F inert is SLFSC. I'll put that in the chat so everybody can see it.
There is an issue with that, Cheryl, though, is that you need to know what to put into that dome overlay. It's not that Quad UI knows what to do with it. You need to know what to put in there.
Oh, absolutely, yeah. But once you know what you want to put in there, there is a method to do it. So.
Just to comment on the APSIM DSAT water uptake, the KL is partly a function for water uptake with less emphasis on root length distribution, and with the DSAT, what you do with the SRGF, which is the shape of the rooting profile, has more impact on the water uptake. So they have different strategies for the water uptake. So if we're mostly finished with questions on that, I could proceed a little bit with a few more of the team's results.
I would just make one final comment that
yeah.
The KL value is largely about, as you say, water uptake, and in Africa in particular, for the sites that I've seen, water parameters are not going to be influencing very much the survey results. They're mostly nutrient limited.
That's good.
So you probably can have all sorts of things for your water inputs, and it's not going to explain a lot of the variability that you're seeing in the on-farm survey yield data. And so F biome, F inert for the APSIM, and initial mineral nitrogen is going to be very important in getting a fit to the observed data. Oh, and soil organic carbon and soil CN ratio as well.
Yeah, I'm good with that. You know, the Ghana locations actually have fairly high rainfall, so it's mostly nitrogen there.
Yes. Mm.
We should note too, there is now a separate factor, SLXF, so that's the APSIM XF factors, which should be input separately from the DSAT root growth factor.
Yeah, the XF is different, totally different.
Yes. I see that the groups that I've interacted with are using one now for their XF values.
Okay, that's good. That's also now the default. If people use the SRG or SLRGF, for APSIM, it will just set it equal to 1.
Okay. Let me keep going with this to the next. This visual is from the Pakistani team. Seem to be, yeah, it's working. Okay. And this is for wheat yield. And what I'm going to show is this is a boxed whisker, but this is not what the survey. This is the CTW for wheat. And there's some things that are a little bit surprising to me, that the two models have a very different yield level. So 30 kilos of N for DSAT and 30 kilos of N for APSIM. So I would say that the team needs to go back and take a look at nitrogen variability, initial inputs, stable carbon, possibly for the DSAT wheat model. Very little response to CO2 under low nitrogen. Under high nitrogen, there is a response to CO2 for both crops, and here the yield levels are closer.
So Ken, I've got it's more of a comment than a question.
Yes.
You know, we've spent a lot of time looking at model-specific ways of initializing the models, the soil organic carbon and the initial nitrogen. But, I mean, an effort should be made to use the same values in both models. And so differences that you see may be differences in the models themselves. We don't want to start with a huge amount of carbon for one model and a smaller amount for the other. That the initial carbon should be the same.
Well, okay, let me comment on that. Absolutely, you should have the same, what I call total organic carbon. That has to be the same, and you have to have the same initial nitrate and ammonium, because otherwise you're saying that that's a real measurable field input. The similarity at that point has to stop, because the models have a different way of handling the soil carbon pools. So F inert and the SOM3 are different, F biome are different. In that sense, they cannot be made the same.
Ken, I would just add that the soil CN ratio, the overall soil CN ratio should be the same also.
Yes. I don't know that we even use that. We make the assumption, I think, in the DSAT that it's 10 to 1.
Oh, okay. Well, it's an input in APSIM.
Ah.
And a lot of the remodel setups that I've seen, the default seems to be 14.5, which means APSIM would be starting with 40% less nitrogen than DSAT.
Ah.
Yeah, Ken, the 10 to 1 is for the series-based organic matter module. The century is each carbon pool is separately set.
Well, but even there, once you set the pool, you set it, right?
Yeah.
We're not allowing an entry in the dome overlay to vary that.
That's true.
I know we had a conversation with Peter Thorburn maybe even 2 years ago that this business about carbon pools, nitrogen, initialization is something that actually would be good to have a little advisory or a whole model exploration, almost in a general advisory to model users. I'm not sure how we do that, but
Yeah, I think it's one of the most difficult things that users have to face is getting these carbon pools set correctly.
the point with this is that what you do with that initializing nitrogen availability changes your response surface to nitrogen fertilizer. And then you have two different model looks. In fact, I'll keep going with this and show there must be the nitrogen response here too. Here's fertilizer application for wheat in Pakistan. And you can see that APSIM is much more responsive to nitrogen at the low end. So there must be a parameterization that is affecting nitrogen mineralization in the model that's quite different from the way they're set up for the DSAT.
It certainly looks that way.
Yep. And if you use an adaptation that says we're going to change fertilization, then you're wrong on your, well, the two models are different.
Yeah.
Now, in his case, they're always at high nitrogen in that region, but it's still a concern. The other thing they had was response to rainfall, and this one I'm not sure why, but the EPSIM was always lower yielding all the way through on everything, so the question is parameterization of those pools. So I would
Or
say
calibration of the cultivar.
well, maybe, but in that case, then what is your standard? What are you trying to, you need to have the mean. Well, here's the other issue with this, Cheryl. Remember we had this thing about picking out the median field to use for both models for the CTWN?
Right.
And if the two models are giving a quite different response, then you can get the accidental configuration of those soils for those fields that may cause this. I'm a little concerned about that.
Can I make just a comment here on the CTWN analysis? According to the protocol, people are supposed to select this medium or typical yielding field to continue to the CTW analysis. But Part B of that protocol says that you need to document the soil, initial conditions, and management factors, etc., that represent that farm. And in the presentations that are coming from the team, we don't get that detailed information of the setup. And so I think they need to take the effort to document which farm has been selected and what the initial conditions, etc., are in management that they're actually simulating.
That's a good point. I like that.
It's not being documented. And I would add another suggestion is that when they show the observed and predicted, you could highlight the actual point on the observed versus predicted to show which point it is that we're actually simulating within the CTWN. And that'll give us a reference point, one on the probability distribution, but also on the observed and predicted.
You're saying that on this sensitivity analysis, one of those points, and well, for example, on this plot, it will be at 0 temperature change. But yeah.
No, I'm going back to step where we choose the farm, the typical farm from the distribution.
From the survey.
We need to identify that and describe it in detail.
Yeah. I'd appreciate any more advice that anybody would like to give on this, because I don't consider that we're totally finished with. We have now figured out how to do the CTWN, and we're learning from it. I think it would be very easy just to jump back and do a different field if we should.
Well, that's a very good point, Ken.
And
The other point there is that in choosing that median level yield farm, it's really dependent on how much calibration, what the actual circumstances are for that particular point. So
Yep.
One, we need to describe it, but also it may not necessarily be typical of what we would expect for that region. And so there is some argument, I think, for doing a CTWN for points at the low end of this distribution, the median, and also the top end. Because I think the interactions with the climate factors will vary as you go across that distribution.
okay.
So, for example, at the low end, you may not get very much sensitivity to any changes in the climate factors because it's so dominated by nutrient stress.
Right.
Whereas at the top end, you might see quite large sensitivity to changes in the climate factors.
Yeah, that's a good idea. I think for the paper, that would be a good way to present it.
I think we need to explore that in some good detail before we actually formulate a polished approach for the paper.
Yeah,
We've
that's true.
explored
It's a
this.
suggestion. Yeah.
And we had observed this, what field you picked made a difference. And
Yeah.
I like this, the low, median, and high, other than creating too many visuals.
Yeah.
Let me ask all of you one more question about this. If you're doing this in, say, Pakistan, India, both locations use high fertility as their standard farms, and their standard condition is also quite often irrigated. So where do we go with getting a good response surface to some of those things? It's the default conditions for that farm are actually good from a water nitrogen standpoint. Any comment, John?
No, I don't. I'm trying to remember the South Indian scenarios, but it's too far back that I can't remember.
Well, IGB is irrigated, fertilized wheat and rice, and in fact so is Pakistan.
Okay.
And this is one of these irrigated wheat fields that's still up on the screen.
Yeah. My sense is that if it's irrigated, it's not going to have a lot of sensitivity to rainfall, but you will see an expression of the CO2 and the temperature effects. And it should be heightened at maximum fertility.
Uh-huh.
That's what I would expect, that the expression of the temperature effects and the CO2 effects would be heightened at high nutrition.
Found another one for South India, and this was the one Yvonne was asking about. This is the figure. This obviously must be, at least I think it's maize, because the yield is high. And APSIM showing no response to rainfall, and the DSAT showing response. So we'll have to figure out what's causing this, okay? We need the details.
Yeah.
It could be as simple as having some sort of trigger that calls for irrigation or not in the translator. Okay. I've got a South India, different one, and this is the one I think.
So Ken, we're at the top of the hour. I think we could ask people if they want to stay. We're willing to stay. I know it's really late for our Australian people that have joined. So I don't know. Should we keep going or?
What do the rest of you want? I have some results from South India and East Africa if those folks want to stay on.
You know, I'm okay to keep going.
Okay. Let's
Might
keep
take
going.
about 10 minutes to go through this, but if you be sure you ask your questions. Here's the South India one. And I'm going to skip through all of the initial protocol here. And this is a probability of exceedance for yield.
So Ken, excuse me, Ken, could you just go back to the previous graph?
One of these?
My point, yeah, either of those. My point would be, it would be interesting to highlight the actual farm on this graph as to which one we're transferring through to the CTWN analysis.
So
Just so that
there are two things here. One would be that you show it on the survey, and the other you show it on the one-to-one graph.
yes, that's right. So show it on this graph and show it on the cumulative probability distribution.
Yeah. Okay. Not sure what the difference is here. 2000. Oh, two different crop models. Okay.
Yes, it's APSIM is over predicting or under predicting. End of story.
Yeah. Trying to figure out which one is predicting. Okay, the y-axis is predicting.
Yes. Yes.
Yeah. Yeah.
Yep.
Maybe
Well,
helpful to put these both on one graph too.
Difficult. Okay. Here's probability of exceedance, and yes, here's where the APSIM is. Yeah, that doesn't look like it's over predicting here.
No.
It's over for some yields.
Yeah.
What I wanted to show the CTWN, because this is the first case where we looked at a legume. The two models are responding to CO2. This is under low nitrogen, 30 kilos, and you'll see that under 180 kilos of N, the yield level is only slightly higher because these are legumes. And they're both responsive to CO2. APSIM not quite as much as the DSAT.
Mm.
And that's probably how they're configured.
Yeah.
Here's fertilizer application, and because it's a legume, APSIM showing no response, the DSAT showing a little bit, and we've got it configured that it does respond a little bit, but it makes up the deficit. So what's interesting is that the farmers are fertilizing this one too. Most of the files that I saw had somewhere between 5, 10, 20, up to 40 kilos of N on chickpea. Rainfall change. Not sure what that means, but maybe this is in the dry season and there's not much rainfall in the first place.
Mm-hmm.
Temperature sensitivity. DSAT showing temperature sensitivity a lot stronger than APSIM. I think this is, we reparameterized chickpea about 2 years ago with temperature data. So the question is the two models different?
You want to know what's going on with APSIM there.
Yeah, this little curve back up really should not be happening.
No.
Yeah.
Yeah, I'll be looking at the setup and the parameterization somewhere.
Sometimes if you have the life cycle being extended with higher temperature, you can actually create a higher yield capability with that. So that's one possibility.
Yeah, check the duration of the crops.
Yeah. And we may be too sensitive in the DSAT, but it's. I think that's the last one on this one.
Can you see that in rice all the time? It shortens the crop duration.
That's okay. Then you should get a little bit lower yield.
Well, it's actually what it does is it shortens the duration and it grows through a more favourable period in the wet season, and you end up with a bigger yield because it doesn't.
I thought this was irrigated, Perry.
I understand what you're doing there. I've simulated the water stress situation, and yes, anything that makes it earlier, you save water to the end.
That's right, and you end up with a better yield.
Yeah, that's true, but isn't this an irrigated crop?
It might be. Some of them, it depends. Some of those fields were irrigated, some were not.
Okay. Yeah.
So this is for the South Indians to address, because I remember seeing the file. Some farmers were irrigating, had 2,000 kilo yields. Some were as low as 100, 200.
Yeah. No, we get the same effect with pigeon pea. It's a long duration crop normally, but under climate change, increasing temperatures, it brings it back into a more favourable part of the season. So, yeah, maybe it's that effect.
Okay, I can tell by looking at the yield levels that this must be an irrigated field. 2,000 kilos?
Yeah.
Yeah.
Yeah, it is irrigated. Only 2 irrigations they will give in this area.
So it's sort of in the middle of that problem. Okay, this is why we're doing this, to explore. One other group, East Africa, if you're still there. And they gave a lot of slides. For the Imbu location, Shredar. And it says chickpea, but I don't think it is. Because chickpea at 5,000 would be fantastic. And Shredar is a little bit catching up with where we are. So I think maybe we need to look at what he's doing and why both models are considerably over-predicting. This is CO2 response.
Can we go back to the previous graph?
Yes.
Is Sridhar with us or not?
Sridhar, can you turn your speaker on and comment? Maybe answer a question?
Yes, I can hear.
I just wanted to draw attention to the fact that the models here are over-predicting substantially, and the reason that I think that is because of the amount of nitrogen fertilizer we're applying. In the survey results, there's an awful lot of fertilizer being applied, up to 180 kilograms of nitrogen, and yet the yield levels, the survey yield levels, suggest that there's nowhere near that sort of nitrogen being applied.
Let me ask one more question before Schrader responds. Is it possible that the fertilizer is in the total amount of urea or some other form and not kilos of N? That could make a big difference.
The fertilizer is nitrogen fertilizer.
As nitrogen equivalent?
Yeah.
Wow.
So the median... the median amount of fertilizer applied in this group of farms is 60 kilograms of nitrogen, and yet the maximum yield in the survey data is 2.8 or 2.9 tonnes per hectare. And there's ample rainfall to utilise the fertilizer, so I think it may be the form of fertilizer rather than the nitrogen content, as Ken was suggesting.
Yeah, then you'd have 1/3 as much if it was urea.
Yeah.
Take a good look at that, Sridhar.
Sure.
Go back to the survey forms and whoever helped with that, because it's very easy to understand. They would have said, okay, this much fertilizer, not this much kilos of N.
Yeah.
Okay.
Good comment. Because both models are doing substantial overprediction, and that is a pretty good evidence. When I see two things, see something happen twice, need to check. A little bit more on this is the CO2 response, and this is telling me this is maize, not very responsive. I think this is good. Rainfall response looks reasonable. Here's the nitrogen response, and maybe...
Can we just go back to the previous graph?
Yes.
Please. It is a strong response to reduced rainfall, and one of the reasons I think is because of the short duration of the season. It's about 400 millimeters in the short rains or long rains, and so if you reduce that amount of rainfall, then you're going to see a yield reduction. So it's particular to this site, I think, that we get such a strong negative response to the change in water environment.
So even though you were saying there was ample rainfall, it was okay at ambient 100%, but dropping...
That's right. There's more than enough in the season that the survey data was collected for, but then this is over 30 years.
Yeah.
As I understand it. So some of those seasons are less than the 400 or 500 that was in the season. I think there was 800 in the actual survey season, but this is sampling a much greater number of seasons.
Okay.
Yeah.
The next one's the one I think that is worth doing some more digging on. Response to nitrogen fertilization. The DSAT response is puzzling to me because it shouldn't be so, well, first of all, too much yield at the low zero nitrogen, at least if you contrast that to Epsom, and yet very, very flat response. So did you get the latest quad UI? There was something in the earlier teams found that the DSAT was not handling the fertilization.
Yeah, previously though, Ken, there was absolutely zero response. So this is,
okay.
Yeah, this is using the correct quad UI.
So then the issue is why the DSAT's showing such a flat response, and I would somewhat argue there that maybe yield is being reduced too much with something like the SLPF value, and not enough with the nitrogen mineralization, the stable fraction SOM3 being regulated. But something in there is related to nitrogen availability.
Again, I see a lot of water stress in these DSAT simulations. I thought the water stress has to do something with this one.
Then we should look at how you're handling the rooting and the water supply. There is an issue with the DSAT, the series maize handles water and nitrogen as the minimum of. So if you've got a water limitation, then it's absolutely limiting response to nitrogen. So we should investigate that.
The same you can see in the rainfall sensitivity. DSAT response is pretty good with the rainfall.
Okay, more responsive to the higher level.
Yeah, and when you come to the fertilizer, it's not that responsive. Then I check the stress factors for each and every year for those fertilizer options. And I see during the grain filling, I have almost like 0.5, 0.6, 0.7 stress coming up in the water.
I know that the DSAT is more water demanding than the Epsom, and what I think we need to do is for you to look at, first of all, we have to admit that we're going to have to use the same water holding traits, you know, SAT, DUL, LL, but the rooting profile and make a substantial difference on this. And if you have good soils that have no impeding layers, maize can root down to 1 to 2 meters. And I think it's a characteristic in your environment that you'll have much better soils depth-wise than in West Africa.
Definitely.
So we should look at that. You and I need to correspond a little bit. Okay?
Sure.
Any other questions for the rest of the teams? I think we've gone through everything I was planning to go through. There are 1 or 2 teams that I still need to follow through. I've not done as well as I appreciate John Dimes and John Hargraves really giving careful attention to all of the teams. And I have 1 or 2 of you that I haven't followed through far enough yet. Any more questions?
Ken, I've got a comment if there's no more questions.
Yep.
So once we've pretty much settled that, you know, people are doing the historical analyses correctly and everything is parameterized correctly, then, you know, then we're ready for this big push on doing the future scenarios and the wraps and adaptations and all those kinds of things, because you'll have this really good foundation to build up those theoretical or hypothetical scenarios. So at that time that we decide that we're ready to move on, which needs to be fairly quickly because we've got the regional workshop in February, end of February coming up, I'm going to want to see data uploads for the harmonized data. So that's the ASB, the DOMES, the ACMOs, and the linkage files. So I'm just giving everybody a heads up. I'll be sending out an email in the next few weeks asking for some data uploads on the CM0, CM1, and CM2. So that's the historical, the current conditions, and the current production with future climate. Okay. So those will form the basis for everything else we do, and I think that before we get to Senegal, we're going to want to make sure that everybody's on board and has at least that much done with their crop modeling.
Yeah, you know, before you do the baseline and the climate scenarios, we need to finish. Some teams are ready, but some are not. And we need to go through the issues with the surveys being satisfactorily simulated, the historical survey. And my goal is for every one of you to accomplish this within, say, the next 2 weeks before we get into, you know, the holiday season here, so that in January you can do the climate scenarios. I hope you're all good with that. Is everybody still on?
Yep.
Otherwise, we're finished. Thought we had a good discussion. Appreciate the contributions.
Yeah, thanks everybody for joining. I think that unless there's any more questions, that concludes our webinar.
Okay. Thank you all.
Okay, thank you.